These rows of small dots are more than just colorful 3D printing. They're also miniature hydrogels that can generate up to 110 volts of electricity. Using these hydrogels, researchers at the University of Fribourg in Switzerland designed a power generator based on the electric eel. An eel's unique ability to generate electricity comes from a specialized organ. When an eel is at rest, the organ does nothing. But if the eel is startled, neural impulses jumpstart the organ, activating thousands of cells called electrocytes. These cells contain a series of positively and negatively charged ions. The eel can reverse these charges at any time, potentially discharging 600 volts through its skin. The power generator works in a similar way. Alternating hydrogels mimic the eel's electrocyte cells and membranes. There are 4 different types of hydrogels. One with a high concentration of sodium chloride, one with a low concentration of sodium chloride, and 2 charged membranes, one negative and one positive. At first, the researchers used a fluidic autosampler to push the gels into sequence in tubes. The more gels they pushed, the higher the voltage they produced. But they couldn't build an array long enough to produce the desired voltage. Next, they tried stacking. These sheets can hold about 2,500 3D printed gels. Each set can produce up to 110 volts of electricity. This was a huge jump in voltage from the previous method, but the current still wasn't high enough. Enter the Miro Ori fold, a type of origami that can connect the gels simultaneously. This instant connection more closely resembled the geometry of the eel's cells and increased the current. Scientists hope to harness this type of natural energy and one day create an electrical system that can operate inside the human body.